time we talk about statistics, we have to talk about what those statistics mean and how reliable they really are. This idea is the idea of critical evaluation. That means when you look at data and studies presented to you, you have to analyze them before you accept the results. You have to think critically about the size of the sample, the way the data was collected, the possible errors in the mathematics that could have affected the results before you buy into them. So there are some problems that we're going to take a look at. The first one is a problem with a sample. The biggest thing is that the sample has to be representative of the population. I used the example in class of surveying people to find out whether or not they liked basketball and how we would get a sample that was representative of the population for Panola College. If you do not have a sample that represents its population, you get what we call a biased sample, and that will result in invalid results. The second type is self-selected samples. These are responses only by people who volunteer to respond. The only people who are going to respond to a call-in survey or a mail-in survey are people who have something they want to say. If they don't have an opinion, they're not going to respond, and that can lead to biased results. The other thing you have to take a look at is sample size. If you have a sample size that is too small, that could be unreliable. The larger the sample size, the better. Sometimes you don't have a choice but to use a small sample, and that can be okay as long as maybe the study can be reproduced and you get similar results. In general, we want larger sample sizes. Undue influence is when the statement in a survey or a questionnaire is worded in a way that already plants an opinion in your head. You may not realize it though. This would be like the Girl Scout cookie question or survey I brought up in class. Maybe one of the questions says, how did you like those delicious cookies? The fact that they stick that word delicious in there means that they are planting the idea that those are really good in your head. That's going to affect your opinion that you report on the survey. Another problem with results can come from non-response or refusal to participate. So if you do everything right, if you get a random sample, it's a large sample, but then 3/4 of those people refuse to participate, all of a sudden your sample size is too small, or it's no longer representative of the population. That changes your results. Now, causality is a big one, and it's a really, really common mistake. Causality means one thing making something else happen. Just because two variables have a relationship, it doesn't necessarily mean that one causes the other. We often say that correlation, just because they're related, does not equal causation. This would be like my son drinking a lot of milk and getting taller. Those things might be related, but maybe he got taller because he got older. Maybe he just grew. The milk didn't necessarily cause him to get taller. So while they might be related, one does not necessarily make the other one happen. You've got to be really careful about that. Self-funded or self-interest studies. These are also big ones. This would be when a tobacco company presents results about oral cancer. You have to be very, very careful and make sure that the study that was done was impartial. That means that the people who did the study don't have money involved or any interest in the outcome as far as getting money from it or benefiting from the study for any reason. You have to make sure that the study is performed by people you can trust. So an example would be tobacco companies studying oral cancer causes. You might come across one by the Crest Toothpaste Company, where that company did a study that resulted in fewer cavities if you used Crest toothpaste over Colgate or Oral-B. That toothpaste company wants you to buy their toothpaste and nobody else's. So of course they're going to present results that say their toothpaste is better. So be very, very careful which studies you believe and which ones you don't. Another common one could be a misleading use of the data. Companies can make their graphs look different and not display the information on them correctly. They also may not show you the whole story. They may just show you a little bit of the data instead of the whole thing to make themselves look better. Now, confounding sort of goes along with causality. Confounding happens when multiple factors could cause a certain outcome, and it's really hard to separate the factors. One example could be looking at data on sunscreen sales and that was wrong. Back it up. Sunburns and ice cream sales. On the surface, it looks really good that as the number of sunburns goes up, you're going to have higher ice cream sales because we all of a sudden relate those two things for being in the summer. But that right there is another factor that we can't necessarily eliminate as causing the increase in ice cream sales. That does not say summer. I can't spell. Can we really determine whether it was sunburns or the fact that it was summer affect ice cream sales? Because sunburns in summer tend to go together with ice cream sales. They're hard to separate. Another one could be activity level and weight gain. On the surface, it appears that activity level directly influences weight gain. We think about a lower activity level going with more weight gain, being higher or a higher activity level, reducing weight gain. But there could be other factors. Maybe you are super active and you have a really awful diet. Maybe all you eat is Snickers. So if all you eat is candy bars, it doesn't matter how high your activity level is, you're probably still going to gain some weight. So the big takeaway is that there appears to be a relationship but there are other factors involved that are working behind the scenes and changing, potentially anyway, changing outcomes.